everybody. Today is Wednesday, December 6th. And today you have the last homework assignment, homework 11 due. And you also have the last quiz, quiz 7 due. Yeah, so make sure you do the quiz. The homework, the absolute deadline for the homework is this Friday, midnight. Okay, and we have 11 homework. We drop the 2 lowest. So make sure try to improve your scores, right? For 9 homework. For 9 homework, you want to get 25 points. Right, everybody? So you all know that we have sample solutions, sample homework solution. Questions?
Yes. So, what if you do all homework 11 and they're all like the same, like they're all 100%? Could we get like 0.1 extra credit for the other 2?
Sorry. Yeah. But I'm happy you do them all because you're ready for the final. Yeah, you need more practice for all type of problems. Your final exam is everything, cumulative. Okay. All right. Do you receive my email about this afternoon? I have the study sessions in Snyder 246. Yeah, please feel free to print out your practice final exam and come and do it. Okay? So let's see. So today we continue on session 7.2. So 7.2, we talk about U substitution. When we see a composite function, we let U be the inner function, right? These are the steps. We let U be the inner function, and then we find the du, and you also have dx on the right-hand side. And then you plug in, you get the integral about U. And then you integrate it. The formula for the antiderivative is basically like this three formula. It's either power function or exponential function or the integral of 1 over x is natural log absolute value of x plus c. Okay, and then after you integrate, you put the x back. And last time we did some examples. I also talked about be careful, some common mistakes. Okay, hello. So yeah, because all of you are here right now. Another reminder, tonight, quiz 7 is due. Make sure to do your quiz 7. And this Friday is the absolute deadline for all the late work, including your homework, your practice exams, your exam correction and wrapper. Is that clear, everybody? And right now, our class evaluations response rate is 67%. We need 3 students to help us to get 100%. So please do it. Right now, everybody will get 0.2 extra credits, 0.2% extra credit. If you do all of them, then everybody will get 0.5% extra credits. Yes. Your comment is also important to me. Okay. The deadline for the class evaluation is this Friday. Yeah. Okay. And this afternoon, I have study sessions in Snyder 246. Do you receive my email? So please print out your practice final exam and come and do it. So today we also take a class photo at the end of the class. So yeah, remind me if I keep talking, remind me to stop and let's do the class photo. Okay. So let's continue. Last time we were working on this problem. It's improper fraction because the degree of the numerator was bigger than the degree of the denominator. So we do long division. Do you still remember the long division process? Yeah, and we end up getting a polynomial and plus this fraction, this proper fraction. Okay, now let's integrate. The two constant multiple stays here. What's the integral of x squared? Blaine? Integral of x squared? Yes. Minus 5 over 2. Will, what's the integral of x?
Sorry. X squared over 2.
Yeah. Can you also tell me the integral of 9 over 4? 9 over 4 times x. Yes. Okay, and then we still have one integral. Do you see the negative 7 over 4? We can put it in front of the integral. Then we have 1 over 2x plus 3 dx. Right, everybody? The polynomial we can integrate using the power rule. And then we're left with this integral. We can move the constant in front. So we just need to find what this integral is. So we let this be, let's say this is the integral I, and we want to use u substitution. What is the u? Yeah, 2x plus 3, the denominator. Then what is the u? The derivative of, yeah, is 2 dx. Don't forget the dx. Dx is like our baby. Don't forget the baby in the mall. Okay, now we have, but we don't have 2 dx, we have dx. So that is how many du? Half du. Therefore, the integral I is integral. The dx is 1/2 du. 1 dx is 1/2 du. Where do you put the 1/2? In the front. And where do you put the du? At the end. So 1/2 here, and then du, we have 1 over u. Yes, everybody? Mm-hmm. And what is the integral of 1 over u? ln u, ln absolute value of u plus c. Now we can plug in the x back. What is u? 2x plus 3. Good. See? We do u substitution, and this answer is the integral I. Now we put it back. We get the final answer for our integral. So we have our answer. So this continue put it. Oops. Let's see. Where's my eraser? Okay, here continue. We get 2 over 3 x cubed, and then minus 5 over. Do you see 2 times 2? 4. X squared plus 9 over 4 x minus 7 over 4 times 1/2 is this minus 7 over 4 times 1/2 is minus, yeah, 7 over 8. And then ln of absolute value 2x plus 3, and then plus c. That is the final answer. So far, so good, everybody? Mm-hmm. Yes. So this problem we use long division, and then we can integrate the polynomial with the fraction parts, we use u substitution. Yes. Quiz? Quiz? No. Quiz is shorter. Yeah. Okay. Any questions about part E? All good? Okay. Let's continue. So, F. What do you want to let U to be? You kind of have some feeling about the U, right? So it's either inside the denominator, or if it's inside some power, right? Or some power, right? Or it's like on the exponent of the E. That's usually the U is. Yeah, in this case, the U is in the denominator. Right, so you recognize there's a composite function, so let U be the denominator. Right? Then what is du? Dylan, what's du? Yeah, 2x plus 1 dx. Oh, but look at the numerator. We have 6x plus 3 dx. How do you get 6x? What do you multiply? Yeah, multiply by 3 on both sides. So we get 3 du is 6x plus 3 dx. Right, everybody? Mm-hmm. So we can replace everything. Remember, we want to change everything in terms of u because you don't want to see a mixture, the integral of mixture of u and x and x, right? It's like you don't like to drink the mixture of milk and orange juice, right? So change everything in terms of u. Now we got numerator is what? 3 du. Denominator is u. Yes. Right, we plug in. So now we move the 3 outside. Exactly, and put the du at the end. Yes, you can jump to this step, right? If you always remember, put the coefficient in front of the integral. The du is always at the end, and then this one inside function become 1 over u. And what's the integral of 1 over u? ln absolute value of u. And what is u? Yes. Right, everybody? Good. So we finished part F. Okay. So this is part F. Here we have more exercise. I will let you to do at home. But do you want to practice just to recognize what is u? Let's see. First problem. What do you think the u should be? Exactly. Second problem. Now, Jay, what do you think the u should be? Exactly. Joseph. Parsi. Exactly. Gabby. Pardi. Yeah, exactly. Do you see the derivative of 2 plus e to the x is e to the x dx? So that is exactly du. Good. And you can see? Yes. So you have the feeling about the u, how to set up the u, and then everything comes. You find the du, and remember your baby here is on the other side. You plug it in, you get the integral about u, and this should be one of those three formulas. X to the p or e to the x or 1 over x, one of those formulas. And then you can integrate and put the x back. Okay, so this is 7.2. Okay, and let's see. 7.3. Okay, area and the definite integral. So, big idea. Sums are an important topic to review in preparations for the geometric concept of an integral as the area under a curve. So we talk about derivative is the slope of the tangent line, right? And we talk about the antiderivative is like the area under a curve, right? How do we compute the area under the curve? Okay. Why do we get those, the notation, the summation, and the dx? Why? Okay. So the area under a curve can be numerically approximated by dividing the area up into thin vertical rectangles of uniform width. Uniform means it's the same width, all the rectangles have the same width, and they have different heights based on the function value. And then we can sum all the area of all the rectangles. More rectangles of smaller width will result in a better approximation. In the limits of an infinite number of rectangles of very smaller widths, the sum is exactly the area under the curve. So big gives. You should be able to compute any given sum. You should be able to approximate the area under a curve by dividing up an interval into rectangles of equal width. Computing the height of each rectangle using the given function, and then sum the area of the rectangles to get your numerical approximation. Okay, so this is what we're going to learn in this session. Okay, so we want to find the area. Okay, how about start with some geometric figures. This is rectangle. Area is length times width. Yes, everybody? And let's talk about parallelogram. So if you have parallelogram with base is b and height is h, then the area is, so remember parallelogram, you can use a scissor to cut this part and put it here. Do you see is a rectangle? Therefore, area of parallelogram is base times height. Yes? And triangle. Triangle is half of a parallelogram. Because you can get one more copy of the triangle and you put it upside down. Can you see you get a parallelogram? Yeah? That's why the area of triangle is 1/2 base times height. Okay, everybody? So if we have polygon, what do we do? Well, you can divide it into many triangles. And each triangle you can compute the area. Right, everybody? And we can also compute the area of trapezoid. But now, how do we find the area under a curve? So this region, we have curved sides. Unlike here, we have a lot of segments, so we can divide into a lot of triangles. But this is curved. How can we compute the area of it? So the method to evaluate the area, we first approximate it by rectangles. And then we take the limits of the area of these rectangles as we increase the number of rectangles. So for example, if you use one rectangle to approximate it, okay, maybe Maybe you draw a rectangle, maybe something like this, right? And if you want to use two rectangles to approximate it, maybe you use this one to approximate it and use this one to approximate it. So you kind of divide the interval to be many rectangles, and then you can calculate the area of each rectangle to approximate it. Okay? So this is one example. You have the function y equals x squared plus 1. You know x squared is a parabola, and plus 1 means you shift the parabola up 1 unit. So the y-intercept is 1. Okay, everybody? Yes? And we want to estimate the area of this part from 0 to 2 with 4 rectangles. How do you cut 4 rectangles? You cut the midpoint, right? And then you cut the midpoint and another midpoint. You get 4 rectangles. So the problem asks you to use different heights for the rectangles. Part A, use the right endpoint. Can you look at the first rectangles? And your function value, it could be from here to here. So you can use the left endpoint as your heights, or you can use the right endpoint as your heights. Or you can use any points based on the problem, and how the problem asks you. So part A, it asks us to use the right endpoint. Okay, so this is part A. It asks us to use the right endpoint. And part B, use the left endpoint. Do you see, everybody? Every rectangle, we use the left endpoint as the height to approximate it. And then part C, every rectangle, we use the midpoint to approximate it. Okay, so let's find the area. So this is 2, and this is 1, and this is 0.5. So what is the width of each rectangle? 1/2. Yes, and all the widths are the same, right? So we cut the area into equal width rectangles. All the widths are the same, and 1/2. So look at the part A. We use capital R. For it means we use the right endpoint as the height, and we cut it into 4 rectangles. The L4 means we use the left endpoint to compute the heights, and we separate into 4 rectangles. M4 means we use the midpoint to calculate the height. Okay, so those are the notations. Okay, so R4. The first rectangle, the width is 1/2. The height, we use the right endpoint. Do you see the right hand point is 1/2? That's the first rectangle. And the second rectangle, do you see the width is 1/2? And f of the right endpoint, what's the right endpoint? 1. And the next rectangle, the width is 1/2. And the height, do you see the height is f of 1.5, which is 3/2? And then plus the last rectangle, the width is 1/2, and the height is f of the right endpoint is 2. Yes, everybody? Then we plug in. So what is f of 1/2? That's 1/2 squared plus 1. 1/2 squared is 1/4. 1/4 plus 1 is 5/4. Right? Everybody? And then 1/2 f of 1. When you plug in 1, 1 squared is 1. Right? And we plug 1. So 1 plus 1 is 2. And then f of 3/2. 3/2 squared is what? 3/2 squared. Squared. 9/4. 9/4 plus 1 is 13/4. Yes. And finally, f of 2. 2 squared. 4 plus 1. 5. Yeah, so we get this, and then we put this in the calculator. We get the answer is 5.75. Okay, everybody? And then L4. So that's the right endpoint. How about the left endpoint? Well, do you see the first rectangle? We use the left endpoint. So this is f of 0. Yeah, everybody? The second rectangle, we use the left endpoint. So that's f of 1/2. And the third rectangle, we use the left endpoint. So which is f of 1. And then the last rectangle, we use the left endpoint, which is f of 1.5 is 3/2. So it's very similar to what we had before, but f of 0 is 1. Okay, everybody? And we get 3.75, which makes sense. Do you see the picture? This area is more than this area. Yeah, so this is bigger, 5.75, and this is smaller. And you know the actual area, it would be smaller than 5.75, and it would be bigger than 3.75, right? So I can see from this picture, probably the midpoint gives a better approximation. Okay, so the midpoint, the width is the 1/2, but do you see the midpoint? The midpoint of 0 and 1/2 is 1/4, right? So that's why it's f of 1/4. And the midpoint between 1/2 and 1 is 3/4. So the height is f of 3/4. The third rectangle, and this is what? 5/4. Yeah, f of 5/4. The last one, f of 7/4. Yeah, and the numbers more complicated, so you plug in your calculator, and then you get 4.629. And you can see this better approximates the actual area. So far, so good, everybody? Okay, so in Applied Calc 2, we will talk about fundamental theorem of calculus and definite integral. And then we will talk about how to actually compute the area of this region. Okay, so in Applied Calc 2. But right now, let's just do the approximation using the rectangles. Okay, let's look at example. Use a right endpoint Riemann sum. So Riemann sum is kind of a name for this. Okay, so this method used rectangles to approximate it is called Riemann sum. So use the right endpoint Riemann sum with n equals to 6 subintervals to approximate the area under the curve e to the 3x minus 1 over 1, 2, 4. Okay. And let's see, what do we get? Okay, so this part, let's see. Okay. All right. So let's draw a picture. So picture can tell us what to do. So make sure you have a good picture. So let's see, get our orange color. Okay, so we have the x-axis and we have the y-axis. And we're interested from 1 to 4. So 0, 1, 2, 3, and 4. Yes, everybody? And let's approximate it. When we plug in 1, okay, so when we plug in 1, well, we get e to the 3 times 1 minus 1 is like e squared. Yeah, everybody? So e squared, I know it's some number positive. So just put an e squared over there. And when we plug in 4, e to the 3 times 4 minus 1 is e to the, is it 11? 3 times 4 is 12. minus 1, 11, right? We plug in x's 4 because we're interested on the interval from 1 to 4. So we get e to the 11. I know it's so big number, but let's just put it here so we can draw the picture to connect them. So this is the region. And we want to cut it with 6 subintervals. So 6 subintervals. And do you see this part? If I cut it with the 2 and 3, I have 1, 2, 3, right? And I need to cut 6. So you just look at the midpoint of them. So this midpoint is 1.5. This midpoint 2.5, and that midpoint is 3.5. So it's up to you to use fractions or decimals. In this problem, because it's E, you need calculator anyway. So it doesn't matter if you put 0.5 or 1 half. You use calculator anyway. Then I would prefer 0.5 because you have less things to type in the calculator. You don't need to involve in the division. Bless you. Right. Okay. So now the problem set use the right endpoint. Look at the first rectangle. Use the right endpoint. What's the width of the first rectangle? Half. Yes. Let's put 0.5. So we are computing the right Riemann sum with 6 rectangles. The first rectangle, I have the width is 0.5 and my height is f of the right endpoint. What's the right endpoint? The right endpoint is 1.5. Yes, everybody? That's the first rectangle. The second rectangle, what's the width? Actually, all the width are 1 half, right? So, okay, 1 half is 0.5. And then the right endpoint, what is the right endpoint? F of 2. Okay, continue. The third rectangle, width is the same. What's the right endpoint? What's the right endpoint? 2.5. Yes, everybody? Plus 0.5 times f of the right endpoint is what? 3 plus 0.5. What's the right endpoint? 3.5. And then the last one, f of 4. Exactly. Okay. So let's try to calculate this. Do you see all of the terms at factor 0.5? Yes? Let's take out the 0.5. I don't want to type 0.5 6 times. Do you want to type 0.5 6 times? No. Let's take out the 0.5. Then I have f of 1.5, f of 2, f of 2.5, f of 3, f of 3.5, and f of 4. Yeah, everybody? Okay, good. So let's continue. So now we can actually plug in. So f of 1.5. You know, f of x is e to the 3x minus 1. So here, e to the 3x. X is 1.5 and then minus 1. plus e to the 3x, x is 2 minus 1, plus e to the 3 times x, x is 2.5 minus 1. Is that okay, everybody? And plus e to the 3 times x, x is 3 minus 1. And plus e to the 3 times 3.5 minus 1. Still okay, everybody? Plus f of 4. So e to the 3 times 4 minus 1. Okay. Yeah, in this process, you need to be very patient and slow down. Okay? Because if you look at the wrong numbers and everything after is all wrong. Sometimes you can also check the pattern to make sure you don't miss any point. Do you see the difference is 0.5? So 1.5, 2, 2.5, 3, 3.5, 4. So if you miss some number, actually you can tell from this pattern. Yes, everybody? Okay, so because I don't want to type everything of these in the calculator, I would like to simplify a little bit. So what is 3 times 1.5? 4.5. 4.5 minus 1 is 3.5. 3 times 2, 6. 6 minus 1, 5. 3 times 2.5 is 7.5 minus 1. 6.5. Do you see the pattern? 3.5 plus 1.5 is 5. 5 plus 1.5 is 6.5. Do you see that pattern? What's the next number? E to the 8. What's the next number? 9.5. What's the next number? Exactly. If you see the pattern, then you can make sure you don't miss some points and you can check the word calculations easily. Okay? So yes, this is the simplified we can make. Now is the time to plug this in your calculator. So plug this in your calculator and get as many digits as your calculator displays. Yeah, use your calculator. Sorry, say louder. Like that? 839. Okay. Thank you. Yes. So this is the answer. This is using the right Riemann sum. Okay, everybody? So if the problem asks you to use the left Riemann sum, then what do? You use the left endpoint f of 1, right? And then all the rectangle, use the left endpoint instead of right. Okay? So any questions about this problem? No? Okay. I want to show you the practice final exam. So this afternoon I have study sessions from 3:10 to 5. So feel free to print out the practice final exam and come to the study session. And the last problem is about this example. So you use either left-hand polynomial sum or the right-hand polynomial sum to approximate the area of your function. Okay, everybody? So and also you have some. This is the u substitution. What do you let u to be? Yeah, yes, very good. So your final exams is gonna be covered up to this example. So whatever I continue next class won't be on the final exam. Okay? Everybody clear? So yes, but still study hard and take notes because it's part of the objective. It's just I don't want to test you something you just learned. Okay, so let's do a class photo together. Okay, class photo. Okay, so let's see. Alright, let's see how does that work. Okay, you can see here. So see here, and let's see how this. I don't know how. 10 seconds. You want us to sit in this room? Yes. Let me see. Okay, squeeze in. So we have this line, see here, and then the back stand. Okay, so come closer. Yeah, you stand. Cage, stand. Yeah. Okay, yeah. Closer. Yeah. Okay, let's see. Let me use the help of this. I can do it. The 10 seconds should work. So.
Yeah, run.
Okay. Yeah. Okay. This work? Everybody? Yeah, good. Let's do one more with some funny face. Okay.
Wait, we have funny face?
Yes.
This is your usual
Yay. Okay.
Yeah.
Anything?
Which
Okay. I will send you the picture. So we still have some time. If you haven't finished your class evaluation, please fill it out before you leave. Yeah, let's do that. Let's see if we can reach 100%. Huh? For what? Oh, okay. I will email her. Yes. Thank you.
Oh, yeah, that's right. We got no more. You see how I texted you? Yeah. You got the A? Yeah, I was like 100 down. I know.
Yeah, do it now.
Oh, are you ready for the status quiz?
See.
What? The status quiz? Oh. You forgot? Yeah.
Have you do it because I still have only 6 students. Do it now. You have extra time. You have 4 minutes.
Wait, what?
The class
You
evaluation.
have 4 minutes.
Yeah. Now it's 10:46.
Until it ends?
Yeah.
It ends at
10:50.
Oh.
Yeah. Do it right now.
Okay.